Vercel, one of the biggest cloud providers today. A company with more than $300 million in funding. A company that lets you deploy your applications on the internet with very minimal effort. But also a company that has a dark side. A company that's often called a wrapper on top of AWS. There are multiple posts criticizing how Vercel gets expensive at scale and it's labeled as a marketing company compared to a tech company. Are these claims true? Have you ever wondered how Vercel works under the hood? Is it really just a wrapper on top of AWS, or is there more to it? In today's episode, let's try to find out how can you build something like Vercel from scratch. Let's get right into it. Alrighty, let's kick things off by understanding what we're building today. We're building a website very similar to Vercel. For those of you who don't know, Vercel is a website where you can go, sign up, link your GitHub, and then it lets you deploy your projects on the internet in a single click. If you look at it here, there's an add new button here. If I click on add new project, it shows me all the repositories that exist on my GitHub. And if I import one of these libraries, for example, the React boilerplate code that I've written on GitHub, and click on deploy, in a single click, it deploys my GitHub repository on the internet. If you want to look at my GitHub repository, it's a very simple React application, nothing much there. We'll see what it looks like once it gets deployed. And that's all you have to do. That's the mode of Vercel. Comparing this to another cloud provider like GCP or AWS, it's much harder to deploy a front-end project there. You have to understand some AWS specific constructs. You have to get a server, pay it $20 every month, $30 every month, deploy your application there. Very hard to maintain it. Versus on Vercel, single click it deploys. Anytime I update my project here, the project here updates as well. If I click on this, the final link that I get is a place where my website is deployed, the code for which resides in my GitHub repository. We will be building something very similar. If you look at the final project that we'll be building, it'll have an input box where you can paste the link to a GitHub project. And if you click on upload, it'll deploy it on the internet for you. By the end of it, the website gets deployed and you get a unique URL that looks like this. If you go there, your React project is deployed on the internet for you. Cool. That's what we're building today. And we're following this blog post by Vercel. The title of the blog post is Behind the Scenes of Vercel's Infrastructure, Achieving Optimal Scalability and Performance. If you read through this blog post, you'll realize that Vercel divides their infrastructure into three parts. Number one, uploading the project files. This involves copying over the project from your GitHub onto Vercel servers. Number two, creating the deployment. This involves actually building your project and spitting out the right set of HTML, CSS, and JavaScript assets. And lastly, the request phase, which involves people from all around the world trying to hit your website and Vercel servers handling those requests. If you scroll to the bottom of this blog post, you'll realize that they heavily rely on AWS constructs. Specifically, to create these three phases, you need only a subset of these AWS technologies. And that's exactly what we'll try to use today to build something similar to Vercel. Next up, let's get into the high-level system design of building a system like Vercel. Alright, building Vercel from first principles. In this section, I'll take you through if I was asked this question in a system design interview, how I would tackle building Vercel from scratch. We have to build the architecture of Vercel. And as you saw in the blog post, and even if I wasn't given the blog post, this is the first thing that would come to my mind. Okay, I need to break this down into three separate services: the upload service, the deployment service, and lastly, a request handler service. What all three of these are, let's look at them one by one. At a high level, the upload service's job is to upload the user code to Vercel systems. It needs to make sure that whatever GitHub URL you got from the user, you copy over all that source code over to your own systems so that you have a good local copy of the project that the user wants to deploy. After this is done is when you move to the second step, which is the deployment service. It needs to deploy, and even before that, build and deploy the project. What does build mean? It means converting the React project over to HTML, CSS and JS files. And what does deploy mean? It means putting these HTML, CSS, JavaScript files somewhere so that other users can access them when they try to hit this website that you've just deployed for the user. Lastly, the request handler service. Once you have these HTML, CSS, JavaScript files somewhere, users from all around the world will try to access them. They'll try to go to Harkirat deploy.vercel.com, and you need to handle this request and return to the user the HTML, CSS, and JavaScript code. That is what the request handler service needs to do. These two are sort of prerequisites to the request handler service. Until a project has been uploaded to Vercel systems and been deployed or built, you cannot actually handle the requests. If you go to the Vercel dashboard, it actually says deploying and the status is yellow. Only when it is actually deployed and the status becomes green is when users can actually hit your service and start to visit your website. Cool. Let's dive deeper into all three of these services. Let's see how I would build 1, 2, and 3 if I was building Vercel myself. All right, let's begin with the upload service. The upload service is nothing but a backend server which needs to take a GitHub URL as an input and needs to copy over all the contents of this GitHub project into the Vercel systems. This is the general architecture I would follow if I was trying to achieve something similar. The upload service will take the GitHub URL as an input, hit GitHub and get back all the contents of this project, basically all the React files, and then push them to what's called an object store. This might be a new thing you might not have heard of. An object store is a place where you usually store your assets. What are assets? Things like MP4 files, images, or even HTML/JavaScript files. You don't store these in a database. If you ever want to store these yourself, you store them in an object store. S3 is the object store of AWS. Google has its own, Cloudflare has its own. You can pick and choose where you want to store these files, but you never store any of these HTML, CSS, JavaScript, React files in your database. You store them in an object store, and the one that Vercel uses, the one that I would recommend also in a system design interview, would be something like S3. Lastly, once this upload service is done copying over everything to this object store, it needs to do one extra thing. It needs to tell the deployment service, okay, I am ready. I have copied over the contents here. Here is the ID of this specific upload. Start the deployment process. How this happens, we will see very soon. But what does the upload service needs to do? Number 1, copy over the contents to S3. Number 2, tell the next service, the deployment service, okay, I have uploaded the project files. Start the deployment. The React files are here. Start copying them over, converting them into HTML, CSS, and JavaScript, and putting them someplace else. With that, let's move to the second service. Until this point, uploading of the source code is done. What needs to be done is actually building the source code. The goal of the deployment service is, okay, bhai, given that we have this project on our S3 now, copy this project over from S3 onto a system, actually build the project, which basically means convert the React project over to HTML, CSS, and JS and put it back into S3 so that by the end of it, we have the final set of HTML, CSS, and JavaScript files that we need to serve to the users in the next stage. It needs to make sure that bhai, a project that has been copied over from GitHub, we actually convert that React code into HTML, CSS, and JavaScript. So what does the deployment service need to do? The name itself has deployment. It needs to make sure that bhai, the code that was present on S3, the React code that's already copied over from GitHub, I build that code, convert it into HTML, CSS, and JavaScript, and re-upload it on S3. Now that we have the final set of files, we can serve this to the end users. The user can actually hit our website and get back this HTML, CSS, and JavaScript from it. How would you build this system is a whole different question we will get to very soon, but I hope you understand what the deployment service needs to do. With that, we'll move to the third service. Okay, given we already have the HTML, CSS, JavaScript assets stored in S3, how do we serve them to the end users? That is handled by the request service. Given कि बंदे ने जो project डाला, the project that has been uploaded to S3 and that has been deployed, how do you serve requests from the user? When a user comes to your website and asks for, okay, give me Harkirat Vercel.app, the code, the HTML, CSS, JavaScript, the website that points to this deployment, the request service needs to go to S3, get back the HTML, CSS, JavaScript files that you created in the last step and serve them to the end user. There needs to be 10 different things here to make it faster. You need to add some sort of a cache here to make sure you're not hitting S3 again and again. But I hope you get the idea. The request service needs to make sure now users can actually access this website. It needs to find what is this ID that this user is trying to visit, and based on that, get the assets from S3 and give it back to the user. Once you have these three services, you have everything that you need in an application like Vercel. How these are built, the actual system design, the services that you would use, we will get down into the next section. Right, before we proceed, a few FAQs, a few standard questions that you should know the answer to in case you're giving an interview. Number one, why is the upload service and deployment service separate? Why can't we do both of these together in a single step? Why did we break it down into multiple steps? Why does after the upload service is done, it signals the deployment service ki haan bhai, I am done, please start the deployment. The reason for this is ki upload service is doing something very simple. Copying over files from GitHub and putting them on an S3 store is simple, does not require a lot of CPU. You can do 10 of these together. So you don't need to necessarily auto scale this service. This deployment, on the other hand, is number one, very CPU intensive. If you're running npm run build, if you're converting a JavaScript project over to HTML, CSS and JavaScript, that requires a lot of CPU. And you don't want upload service to be affected in case there is one project that is taking up a lot of CPU on a machine. It is for this reason you use an architecture like this. Bhai, upload service is separate, simple, even one server will run. There is a single server that is handling upload. Multiple people can hit this single server. It will do what it's supposed to do. But the deployment server, the server that actually needs to run npm run build, at a time, only a single project should be running on these deployment servers because they can take up a lot of CPU. They are also running arbit code. When you run npm run build, you are taking whatever the user uploaded and running npm run build on it. You are converting their React project into HTML, CSS and JavaScript. You want to do this in an isolated manner, which is why you should separate upload service, the simple stuff, and the deployment service, the extremely complicated stuff. And the deployment service needs to make sure only one server is handling one request at a time. No two builds are happening on the same server. And if a build is happening, it is running in a very isolated manner because you're running arbit code, you're running code from other people on your machine, and you want to make sure you isolate this very well so that your server doesn't blow up. Cool. That's the first answer. Number two, what does building the project even mean? If you've done some basic React in the past, you might have run the command npm run dev to run it locally. But when you actually deploy it on the internet, for a React project at least, you first convert that React project into simple HTML, CSS and JS files, and then you serve these files as normal. You don't have to do anything extra. Whatever was your method to serve these HTML, CSS and JavaScript files for a raw project, by raw I mean a non-React project, the same you can use here. So this process of converting React into HTML, CSS and JavaScript is what's called building the project. And this is the CPU intensive task that I talked about. Number three, Harkirat, why did we need to serve HTML, CSS and JavaScript files? Why can't we directly serve React? And the answer here is your browser does not understand React. Your browser only understands HTML, CSS and JavaScript. This is a common standard pattern. If you're writing a React project, you will first convert it into HTML, CSS and JavaScript. That is what your production server will serve. You never serve React files into a browser. Your browser doesn't even understand React files. Lastly, another good question an interviewer might ask is this approach valid if you are doing this for a raw HTML, CSS, JavaScript project? The answer is yes. If you're doing this for a raw HTML, CSS and JavaScript project, you don't have to worry about the deploy step. You can simply, take the GitHub project, upload it to S3 and you're good to go. You are uploading the HTML, CSS and JavaScript files upfront. The project isn't even the React project. It had simple JS files. You copied them over and you're good to go. You don't need a deployment stage. The same question can be twisted. How will this work for a Next.js project? Where the answer is no. You have to change the approach a little bit, but that's out of scope for this video. Next Vercel does do that, but the architecture that we're talking about will only work for React projects or HTML, CSS, and JavaScript projects. It will not work if you bring server-side rendering into the picture, which out of scope for this video, happy to discuss in a different video. Cool. With that, let's get into some teachy bits. I'm going to now go through some slides and explain all the 3 stages one by one. It will be slightly repeated, so feel free to skip the next section. Feel free to fast forward through it as well. All right, let's try to comprehensively discuss this architecture one more time. The Vercel architecture is divided into 3 parts: the upload phase, deployment phase, and the request phase. Let's start with the upload phase. What did we discuss? During the upload phase, the user will send a GitHub URL to the upload service, to the upload server, whatever you want to call it. And what does the upload service need to do? Number 1, it needs to clone the project from GitHub over to this server. And number 2, it needs to send that cloned project over to S3. This is the final persistent place where this GitHub code will be stored. It will be deleted from the upload server after this. And then comes the most important part. If this did succeed, if the upload server was able to put the full project on S3, it needs to signal to the deployment service, okay, bro, I am done. Start the deployment process whenever you are ready. It needs to asynchronously talk to another backend service. Here I will introduce a new term called queues, which is an efficient way for backend services to talk to each other. In this case, what does the upload server need to do? It needs to tell another backend service कि हाँ भाई, I have done uploading, please start the deployment. But the upload server should not directly hit the deployment server. It shouldn't directly tell the deployment server कि हाँ भाई, I am done, start deploying the next project. The upload server should put this in a queue. It should be like, this is the ID of my recent upload. I'm going to push this onto a queue. And then the deployment server can pull things from the queue. Harkirat, what is the benefit of pushing it to a queue? Why can't the upload server directly talk to the deployment server? In the end, the same thing is happening, right? Upload server is pushing something to a queue. Deployment server is pulling from it and actually deploying the project. Why can't the upload server directly talk to the deployment server? Great question. The answer is, okay, the deployment server that's sitting here might not be free. It might be running a different deployment. It might be running an old deployment. The upload server should not be directly telling the deployment server, okay, bhai, run this. It should be asynchronously telling it, okay, bhai, I am putting it in a queue. Whenever you are free, just pull it. And then whenever a deployment server does become free, it can pull it from the queue. The upload server shouldn't directly signal to the deployment server, okay, haan bhai, start deploying. Okay, that's the reason why you want to push it to a queue. And what is the queue that we're using? It says SQS, which stands for Simple Queue Service. It is an Amazon service that basically lets you do this exact use case. It lets you push things on a queue and lets other services pull things from the queue. This isn't the only way to push things on a queue. There are multiple other protocols, some of them being open source, which you might want to use. You don't have to use SQS, but SQS is the service that Vercel uses. And what is SQS? It is a simple queuing service that lets you put things on a queue and lets another service pull things out of the queue. What are the other open source versions you can use? You can use Redis queues. You can use something called RabbitMQ. There are multiple other open source queuing systems as well, but the one that Vercel uses is SQS. Once the upload service has put this on the queue, okay, bhai, I have put it on the deployment queue. Eventually at some point this will get picked up. The upload server can give the ID back to the user as well. If you remember initially, when I put the GitHub repo in our final project, I clicked on the upload button. After some seconds, it gave me back an ID. It told me it has been uploaded and is now deploying. That ID, the front end needs to get from the backend, and that is the last stage. The upload server, once it's done, number 1, pulling things from GitHub. Number 2, pushing things to S3. Number 3, putting things on a queue. It should tell the end user, haan bhai, good to go. This is your ID. Use this to track whether or not the deployment has succeeded. The upload has succeeded. Here is your ID for it. That's all for the upload stage. The only extra thing I introduced here was the queuing bit. After it's done doing its thing, it puts the final ID on a queue so that the next service, the deployment service, can start pulling things from the queue and actually deploying the project. We're done with the upload phase. What are the AWS technologies we used? We used S3 for uploading the files. We used SQS as our queuing system. Next up, Let's look at the deployment phase. The deployment phase starts from the SNS queue, the queue that is being filled from the last step. The upload phase is uploading the files and pushing things on this queue. And who is pulling these things from the queue? It is the deployment servers, the build servers, whose job is, okay, bhai, number one, pull things from these queues. Number two, start to process them, start to build them, start to convert React projects over to HTML, CSS, and JavaScript files. Once that is done, let's say worker one was able to build the project and finally created the final build, which is the HTML, CSS, and JavaScript files. It pushes them to S3. It isn't necessary that all of these run at the same pace. This might be a very big React project. This might be a very small project. Each worker independently is doing its job. You can auto scale these workers. You can have 1 worker, 3 workers, 5 workers, depending on how long your queue is. And as time goes by, this queue will become smaller as the workers pick up these builds. It also might go longer based on how many people are uploading projects and how the queue is being filled. In the end, the goal is this queue doesn't become very long and you auto scale your servers up if you feel like there's a lot of traffic. If there isn't, you can auto scale your servers down and make sure there's a single worker running that's handling all the builds. In the end, as time goes by, what do these workers need to do? Process the files and then move on to the next file. For example, the worker one first picked up file number 7. After it was done deploying it and publishing it to S3, it then picked up the project number 4. This is how the queue gets getting popped off. That's all that the deployment service needs to do. By the end of this step, you will sort of have 2 copies of your project. The original React code base that you wrote and the final deployable HTML, CSS, JavaScript files that the deployment servers in the last step created. You effectively have 2 copies of your project, the original source code and the final assets that you serve to your end users. That's all for the deployment phase. If you look at the AWS constructs that we used here, we used S3 for uploading the final assets. We used SQS for pulling things from, and we can use EC2 instances, which are basically AWS servers to run the final build pipeline, and something called AWS Fargate that lets you auto scale in a fashion like this. If you have a use case where you number one have a queue and based on the length of the queue, you need to auto scale up or auto scale down servers. The best stack that you can use, not the best, but like the easiest stack to just get off the ground is this stack. Are there fancier stacks, Harkirat? Yes, you can use Kubernetes for this. You can use something called auto scaling groups in AWS that let you do the same thing. But a nice common stack, if you have a use case like this, a queue plus auto scaling servers, you usually use Fargate with EC2 instances. All right, that's the second stage. Last stage is the request phase. This is the chill bit. You have already done all the heavy lifting. You have copied over the project. You have built the project and stored it. In the last phase, what Vercel does is, as people try to visit your website, as they tend to ask for the HTML, CSS, and JavaScript, if they visit it in the browser, Vercel sort of has a fleet of servers all around the internet, and it routes the request to your closest server. For example, if you ask for id.vercel.com from US, your request will go here. If you ask from India, your request will go here, so on and so forth. After your request reaches here, it needs to extract the ID. This user is trying to access this specific website. Once it has the ID, it needs to get the HTML, CSS, and JavaScript bits. It needs to not get the React project. It needs to get the final build and just return it to the user. That's the last phase that we need to support. More specifically, when we're writing the code for this, we need to write the code of this black box. This server that will take requests on id.xyz.com, extract the ID, forward the request to S3, get back the response and return it to the user. There should ideally also be a caching layer here so that if multiple users are asking for the same thing, you cache them here on the server. You don't forward every request onto S3. All right. That's the architecture for the request phase and we're good to go. The things that you might use here, we will not today, but if you want to really build it in a globally distributed fashion, Amazon Cloud Accelerator and Amazon Global Network basically let you create anycast IPs, allow users to hit a single URL and their request to get routed to the closest AWS server. We won't be doing any of this today, but if you want to really create this at a global stage and give the benefit of closest servers to your end users, you ideally want to use something like AWS Global Accelerator or AWS Global Network. Lastly, the other thing that Vercel uses we want today is Amazon EKS. This basically lets you create a Kubernetes cluster inside AWS. For Vercel specifically, all of this request handler code is put inside a Kubernetes cluster, which is why you need EKS. If you want to deploy it raw, if you don't want to use Kubernetes, that's fine as well. You can bring up a server any way you want. This is a simple express server that just needs to, forward a request to S3 and get back the response. Cool. These are the three services we will be coding next: the upload phase, the deployment phase, the request phase, and also a simple React project for the front end where people can come and deploy your application. Let's get into the coding bit. All right, let's get into the coding bit. I want to add some structure to the coding part so you can follow along if you want. I'll be coding everything from scratch, but I've written down all the points in some small digestible chunks. So if you want to code along, you can. If you want hints, there are hints to each and every point. For example, if you don't yet have Node.js on your machine, you can toggle this and look at a few hints as to how you can do it. Generally, I would urge you to look at the point and try to chew some glass and try to code it yourself. If you don't understand it, there are solutions all along. And there's also me coding on the side, but generally the best way to learn is code yourself. Where can you find this? You can go to projects.100xdevs.com, and over there's the code along Vercel track where you'll find all of these steps for all the tracks that we're covering today. This is the first service that we're building, the upload service. There are 4 parts to this: the upload service, the deployment service, the request handler service, and the front end in React. So we'll be writing all of these from scratch, and you can follow along using these steps if you want to code along with me. With that, let's get right into it. Let's move on to the first point over here that says install Node.js. If you don't already have Node.js, good time to do it if you want to code along with me. There are a few instructions here. I already have it on my machine, so I'm going to skip this step. The second step is initialize an empty TypeScript project. For those of you who don't want to use TypeScript and just want to use JavaScript, I would urge you to not do that because it will be harder to follow along this tutorial. You don't really need TypeScript for this one. You can work just with JavaScript, but generally a good thing to learn. I'm not going to go too much into the depths of TypeScript for this one. So as long as you follow the steps that are written here, create a basic TypeScript configuration, you're good to go. You don't need to write a lot of TypeScript code. Basic JavaScript code should be fine. All right, I'm done with step 2. I've been able to create an empty package.json file and an empty tsconfig.json file. These are the steps that you need to initialize an empty TypeScript project, which is exactly what I've done here. The third step is a basic TypeScript configuration. This really depends on you, how you want to do it. Generally, the way I do it is I make sure that my root directory is /source. So all my source code will be present in a top level root directory called src. And my out dir, which basically is the place where all my JavaScript code comes out. All the TypeScript code eventually gets converted to JavaScript. Where does this go out? It will go out in this root folder unless you change this out dir to something else. Common practice is to change this to either /dist or /build. Feel free to pick and choose. You can totally skip this step as well. This is a better way to structure a TypeScript application. We're done with 2 points. No, we're done with 3 points. Let's move on to the 4th point, adding a few dependencies to our project. I've taken the leverage to decide what libraries to use. There are many ways to create an HTTP server. You don't have to use Express. There are many ways to do queues. I want to use Redis to have minimal dependency on AWS, but you can use SQS, the service that Vercel actually uses. You can use RabbitMQ, really depends on you. The AWS SDK, because we have to interact with AWS, we actually have to put some data in S3. This also means you will need an AWS account. I'll show how you can get one very quickly. Simple Git. This is a NPM repository that lets you basically run Git commands. You can run it without simple Git as well. You can execute a command in Node.js very easily, but this sort of gives you very nice functions to do it. So this is an external library we're using. And finally, CORS, for those of you who know, frontend and backend, if they're hosted on separate ports or like separate backends, separate URLs, you should use CORS. This is a library that introduces CORS to your backend. What it is, sort of out of scope for this video, but a library that you need for this specific video. How do you install all of these dependencies? If you've done Node.js already, the way to do that is this command right here, npm install and all the dependencies that you need. As you can see, I've added some extra dependencies because we are using TypeScript. And if you want to bring types of libraries like Express locally, you have to bring this @types/library name npm module locally as well, else you'll get TypeScript errors all across. All right, let's run this command. And we're done with the first 4 steps. All right, let me take a pause here. This isn't a merge stack video, which basically means I'm going to do a few things from now on, which might, go right over your head if you've not done the merge stack before, don't understand Express, don't know what HTTP servers are. Feel free to stick to the video. Feel free to, hop off if you don't understand it. But I'm not going to explain everything I'm doing. I will, of course, at a high level explain what's happening. But if you've never done Express, or, if you don't know what an HTTP server is, after this point, things are going to get overwhelming. Feel free to follow along if need be. But rather, go to a basic merge stack tutorial, understand what an HTTP server is, and then come back here so that you're actually able to make some sense of what's happening. All right. With that, let's move to the next point. It says next point is initialize a simple Express app in index.ts and listen on port 3000. If you've done Express before, I'm hoping this is straightforward. You should also add cores to it because our front end and back end are going to be different. All right, that's all that was expected from this point. What have we done? We've initialized an empty app from the Express module. What is the Express module? It is an NPM module that lets you create an HTTP server. Is this the only one? No, there are many ways to create an HTTP server in Node.js. Can you do this only in Node.js? No, you can do this in Java. You can do this in any backend language, Golang, Rust. Every library will have its own set of popular frameworks to do this. The most conventionally popular one on Node.js is Express, which is the one that we're using today. This is a basic boilerplate code that lets you start an HTTP server locally so that people can hit your backend server. How do you know if this is running locally or not? Number one, build your project by running tsc-b or npx tsc-b. That will build your project. That will convert this index.ts file into some basic JavaScript code here in dist/index.js. It will only be in this dist folder if during the initial configuration, you change the out dir to /dist. If you change this to build, then it will be in the build folder. If you did not change this to anything, and if you have it still commented in your original configuration, you will find index.js in the root folder. Once you have this index.js file, you just need to run it using node. So the command to run is node dist/index.js. If you run this, and if you see your terminal is hung, basically means your server is running correctly. How do you confirm 100% if it's running? Go to localhost :3000 and make sure you see a page that looks something like this. If you don't see this, if you see something like this, that means there's a problem. If you do see something like this, that means your HTTP server is good to go and you can move on to the next step. The next step says initialize an endpoint that the user will hit and send you the repo URL as the input. What does this mean? This means in your final application, when the user will go to an input box, put a GitHub URL and click on a button, the request that goes out, you need to create an endpoint to handle that request. All right, I've written some code. What this does is initializes a single endpoint that the user can hit, a backend endpoint. And when will this specific endpoint be hit? This will be hit when the user puts a repo URL and clicks on the submit button. Once that happens, the control would reach here. We're expecting the user to send the repo URL in the body of the request. This is the actual GitHub URL, for example, github.com/harkirat/react boilerplate. Once we have this value in this repo URL variable, I'm just logging it on the screen right now. Eventually, of course, we have to do a bunch of things here, clone the repo, put it on S3, all that jazz. But hopefully until this point, if you know Express, this is straightforward. If you don't know Express, I can tell you this starts an HTTP server, exposes an endpoint that your front end can hit. And here is where we have to write the meat of the logic to clone the repo, actually put it in S3, so on and so forth. One quick call out here. If you want to extract the body from a post request, you need to use a middleware like express.json. If you don't do this, request.body will always be undefined. Why does that happen, Harkirat? Long story short is Express doesn't know / doesn't care as to what this body is. This could be a string, this could be JSON, this could be binary data. And so Express expects you to use the respective middleware based on your input data. In our case, the input data is going to be JSON, and hence I'm using the express.json middleware. If it was something else, I would have to use a different middleware. This is a great starting point for your application. You have bootstrapped the application. You have created a basic boilerplate code. Now we have to write the meat of the logic that will actually put things inside S3, the logic that will actually clone the repository. The next point says, create a function that randomly generates an ID for this session. Call it generate. This basically requires you to create a function that will generate a randomly generated ID. If you go to vercel.com and you create a new deployment, every deployment has, not logged in here. If I go to vercel.com, look at any of these applications that I have deployed. Every application deployment has a unique ID associated with it. For example, this one has a very long I, if you can see it, IAZ9V5, so on and so forth. You give a unique ID to every deployment of yours. The same thing if you want to do here, you have to first generate a function that will create a random ID. You can create it inside this file if you want, but I would urge you to create it in a separate file so you have some better structure in your application. I'm going to create a file called utils.ts, which is the worst idea ever. Never name a file utils, but since this is a small project, it's fine. Here I will define, what does it say? A function that randomly generates an ID. All right, I have written this function called generate. Let me export it as well. This function will generate a random string of length 5. How do I know if it works? I copied over this whole code. I opened my terminal. I ran node over here and then pasted this whole code. Everything, it will not work with the exports. I would remove the export and then paste it. And then when I call generate here, it gives me a randomly generated string with 5 letters, which is a random ID for my deployment. You don't have to test it this way. This feels a little too complicated, by the way. As long as you are confident in your function, or just, log a generate function call and make sure it works as expected, you're good to go, and you've written the function that was expected in this point, an ID generation function called generate. Next up comes the most moti bit, by moti I mean MOAT, moti bit of this specific application, which is use simple git to clone the repo into a new folder. All right, what is simple git? Let's start there. Let's search for simple git on Google, and it tells us that it's an NPM module that you can use to basically clone repositories, a lightweight interface for running git commands in any Node.js application. Do you need it? No, you can still run raw git commands by using something like spawn in Node.js, but this just gives you a slightly cleaner API to deal with. We've already installed it locally, so all we have to do is use it now. I'm going to import it at the top. And I'm going to run the clone function here that lets me clone this specific repository that I'm accepting as an input from the user. All right, I was able to do what's expected. Let me share how I did it and the tools I used to actually test that the thing is working as expected. Number one, I used the simple git repository to run a simple git.clone. How did I reach the function signature is a good question. I've done this before, and also I was able to basically go inside the library and look at the arguments that it expects. The arguments that it expects is repo path, which is a string, and the local path where you want to store the finally cloned project. And what inputs have I given? I've said by whatever repo URL comes as an input, clone it, run git clone on that repo URL, and store it in the output/ID folder. And this ID is what? This is the randomly generated ID that this function runs that we wrote in the last section. So anytime the control reaches here, number one, we randomly generate a 5-letter ID. Number two, we clone the repository that the user wants us to in the folder called output/that randomly generated ID. I've also tested this locally and I know that it works. Let me share how I tested this. There are multiple ways to test your Node.js application. Basically, what do I want to do? I want if I open my terminal, if I compile this application, and if I run it locally, I want to hit this endpoint somehow. I want that the control reaches here somehow, similar to how the control would reach here eventually when the front end hits this endpoint. How can you test this? One very famous way to test these endpoints is something called Postman. What does Postman let you do? Postman lets you send requests from this very nice GUI on a specific URL, on a specific route, and also lets you send body inside. So what would you have to do at this point? Number one, install Postman. Number two, you might have to sign in here as well. And then number three, put the URL to your backend server here, which in our case is localhost:3000. Where does localhost come from? It's basically the URL that points to your own computer. You can also use 127.0.0.1 here. Localhost is a commonly preferred one. Where does 3000 come from, Harkirat? It comes from here. Our app is listening on port 3000. That is why I was able to go to my browser on localhost:3000. So since our app is listening here, but I cannot send a post request from my browser, I will send a post request from Postman to the /deploy endpoint and send in the repo URL. And if you look at it, what happens when the control reaches here? We extract the repo URL. So if the input repo URL is this github.com/hkirat/react-boilerplate, that is what gets cloned here using simple git in the output/id folder, which basically means all the files from this Harkirat React boilerplate repository, which is all this code right here, comes to my local machine thanks to the code that I've written. How can I test this? Number one, start the application locally. It's already running for me. Number two, send a request from Postman. It takes some time, but eventually no logs here. A simple object that's returned back, which is the same thing I'm sending here, which basically means things seem to have worked as expected. But let me confirm. Let me exit out from this. Let me press the ls command to look at a newly generated output folder. As you can see, output/id is where I wanted to clone the repository. And did that actually happen? Yes, there is a randomly generated ID here. If I go to this folder, I see my repository cloned locally in a folder called output/jdl87, which is the uniquely generated ID. One thing I should probably do is return the ID from here so that the front end can use it to track it. Do you remember we talked about this? Okay, after a few things happen here, we actually put this to S3. We want to return the ID back to the user, which is why I can write this code. And now if I recompile the project and run node dist/index.js, and if I go to Postman and try to hit it, the response that I get back is ID and a randomly generated ID. This I can then show on the front end because this request will eventually go from the front end. Right now it's going out from Postman because this is a library that you can use to test, not library, like an application you can use to test out your HTTP routes, but you don't have to. You can actually start to write the front end code already. Just so we have some structure, we are going to first complete this and then eventually reach the front end bit, but we will keep using Postman to make sure everything works as expected, which in our case, until at this point, everything works as expected. We are able to clone a repository locally into our machine. Let's move on to the next point, which is write a function that gets the paths of all the files in out/id. Let's talk a little about why we have to do that. All right, let's talk about why are we creating a function that gets all the paths of all the files in /out/id folder. What do we want to do from here? Given that we have cloned the repository, we just need to take the output/id folder and put it inside S3. We already imported this library called AWS-SDK. Wouldn't it be nice if this SDK just gives us a sdk.upload to S3 or upload directory to S3 and then give it the paths of output/id and we're good to go? It would have been nice, but from my knowledge, and this could totally have changed now, there is no easy way to upload a directory to S3. You can easily do sdk.upload file, but you cannot do sdk.upload directory, which basically means we need an array of all the files that we have, for example, /kirat/users/project/vercel/output/12345/ app.tsx. That's the first element, and then so on and so forth. We need an array like this, which has all the files so that I can iterate over this array and then call sdk.upload file one by one, because there's no easy way to just call sdk.upload folder. Cool. So what's the first thing we have to do? Generate this array that finds all the files that exist, or the paths to all the files that exist in this /output/id folder. Let me write the code for that. Right, that took longer than expected, but I was finally able to create a function called getAllFiles, which gets me all the files inside the output/id folder. There are a few things that I have changed. Specifically, this path.join might seem very new to you. As I debugged, I realized it's a good to have. You don't need it, but it will give you very nice absolute paths throughout your project. What do I mean by absolute paths? Basically, in Node.js __dir name gives you the current directory that you're in. It won't run if you run node here like this and try to test it. But if you log __dir name, for example, if I put a log here, console.log __dir name, and if I rebuild the project and rerun it, you see it says /users/Harkirat/Vercel/dist. So basically is where my code is running from, where the index.js file finally runs from. Now, throughout my project, I am using absolute paths. I'm doing a path.join __dir name, comma, this thing. What is path? It is another npm module. This comes by default in Node.js, I think. So I can just import it at the top. And rather than doing, clone it to here, I'm saying, don't clone it here, because this way it creates an output folder where in your root folder. I don't want this output folder to be created in my root folder. I want everything inside dist. So I say I could either do this, store it inside dist/output/id, or the cleanest way is, store it inside this. What is this? Let me log it again here. Rather than doing a console.log _dir name, let me do this. And you will see what gets logged: /users/Harkirat/Vercel/dist/output/random string, which means now we are storing everything inside the dist folder, including the Git repository that we are cloning. Do we have to do it? No, you can still store it in the root folder. This will just make it very easy as we go down the recursive path of finding all the files in a folder. So would urge you to do two things. Number one, get comfortable with path.join. Number two, get comfortable with __dir name. Both of these, this is standard pattern you'll see in many projects whenever you want to do absolute paths. What do I mean when I say absolute paths? I mean this whole very long string or a very long path right from the root folder up to the current folder that you're in. Cool. That is what we've done here. So now even if I comment this getAllFiles functions that I've wrote, even the function call above, the simple get.clone function call, has changed a bit. Specifically, rather than storing everything in the root folder, now we're storing it in the dist folder. Cool. Given we've done that, let's see what I wrote next. I said const files equal to getAllFiles and then console.log files. Let's see what this outputs to, and then we look at the code. If I go to Postman and do a clone of this specific project now and look at the logs, you will see it logs all the files in my React project. /users/Harkirat/Vercel/dist/output/ the unique ID /.git/hooks/ something. A more meaningful file here might be this app.jsx file right here. /users/Harkirat/Vercel/dist/output ID src app.jsx. I have the paths of all the files that I want to upload to S3. I can now simply iterate over this array and call the s3.upload to actually upload it to S3. The question is, how did I write this? Why is there no easy way for us to write this in Node.js? I had to, go through a lot of recursive maths to get this done. Let's see what's the code that I wrote. And if you find a better way to do it, let me know. I don't think there's a better way. But let's look at the code that I've written. I first imported FS at the top, which stands for the file system library. It lets you do a bunch of things on your file system, like read files, read directories. And specifically, it exposes a read dir sync function, which, as the name suggests, lets you read all the contents of a directory. So what does the get all files function get as an input? It firstly gets this /users /Harkirat /Vercel /dist /output / that's it. /random ID, one. That's what it gets as an input. What does it need to return? All the files in there, not just in the root folder, every recursive folder. My React project, if you look at it, the project that we're cloning, has a bunch of files, not just in the root folder, but also in recursive folders in src/app.jsx, app.css. We need the paths of all of these. And for that reason, we have to write mildly complex code. The fs.read dir sync function only gives you all the files in the current folder, does not give you recursive files. If it did, our life would have been very easy. It gives you all the files in the current folder. So we get all of those files. And as you can see, this variable that I'm storing it in is all files and folders. It gives you all files and all folders in this specific input folder. And then I iterate over them and check, okay, bhai, is this specific file a directory or not? If the specific file is not a directory, which means the control reaches here, I push this to my final output array. This is the thing that I'm returning in the end. Let me remove this logic. Our life would be very simple if we did not have a very recursive folder structure. But unfortunately we do, which is why this code isn't enough. This code though is fairly straightforward. Okay, bhai, get all the files and folders, and for every file, do a path.join current folder and the file, because the file path is not the absolute path from root. And what we want to store here is the complete path. You can also log this and check why, I had to do this. Path.join here. The file name will basically be, whatever, app.jsx. But what I want to store here is the full path. So I take the folder path, the root folder path, which will be, this thing, and I add this to app.jsx. That's what path.join folder path and file does. So by the end of it, I'm able to store everything in this responses array. This would have worked if we did not have a recursive folder structure. Since we do, we have to do two checks here. Okay, bhai, if this is not a directory, then we are sold. But if this is a directory, we need to recursively find, let me expand this a bit. We need to recursively find all the files in the subfolder and concatenate that to our response. So what will this code do? It will recursively call the same function. It calls the same function again with a directory that might look something like this /dist. So full file path might be /src/assets. And then the function will get called again. It will return the set of files in that folder. And then you concatenate that to the response. Harkirat, why not do a push here? Why do a concat? What does push do? Push, what will this return? It will return you an array. Do you want responses to look like this? Array of array file.txt, comma, an array of assets/file.txt. We don't want responses to look like this. But if I do a response.push here, it will push an array to responses. I don't want to push an array to responses. I want by whatever is inside, whatever gets returned from get all files, which is an array of strings, concatenates to this responses array, which is why I have to call the concatenate function, which will take the response and concatenate all the rest of the files that get all files returns you. And this is how we recursively create this function. If you don't understand, you chat GPT, you ask, give me a function that gives me all the files, and it does. But generally good to write this yourself. I did not have to spend like 30 minutes doing this. But I did because, good to have your fundamentals clean. That said, this is something that you can totally abstract out and, ask chat GPT to code for you. And by the end of it, if this does work, which as we saw initially it does, it will give you an array of all the files that exist in this output folder, which basically means it will give you an array of all the GitHub files that you've cloned. And now you just have to do something like this, right? Files.for each file. For every file, do a s3.upload. Now, where does s3 come from? We'll see very soon. But if s3 gives us a simple function to upload a file, all I have to do is this, and my life is sorted. I have created the logic to do the first part of my code. There are still a few things to do. I'm going to revert this, but at least hopefully you understand how you can extract all the files given a input directory, specifically the input directory being the place where we have cloned the repository, so that we get all the paths to our final Git repository that we have cloned, so that we can start to publish this or put this on S3, which is our object store. Let's look at what the website expects next from us. We've written the function that extracts all the paths out. We have to create an AWS account next, because now comes the bit of actually uploading to AWS. Most of you might not have an AWS account. They require very strict checks and debit cards. So I'm almost completely sure if you don't already have access to AWS, you won't be able to do it without a decent credit card, debit card. So you can do one of two things. You can either follow along without using AWS, which basically means, won't code, just look at it. You can ask a friend for it. Or thankfully, there is another cloud provider called Cloudflare, which gives you something very similar to S3. What was S3? S3 was an object store. It lets you put MP4, MP3, .jpeg, JSX, HTML files. Anytime you want to put any of this, you put it where? You put it on AWS S3. What happened was, this basically became a very big service, and then all cloud providers wanted a piece of the pie. So Cloudflare, which is another very big cloud provider, the name itself has cloud in it, said, "Ke bhai, we have created a complete copy of S3. We are calling it, I think, R2 or something like that. And we have kept the SDK completely similar to that of S3. Because they knew everyone was on S3, everyone was on AWS, and they want everyone to move here. They said, "Ke bhai, you write your code like you do in S3. Just change one small thing, and that will start to upload your files to R2 rather than S3. And R2 is cheaper, R2 is better. R2 also you can easily get an account on compared to an S3, which is why we can still use the AWS SDK NPM module, but we can upload to Cloudflare and not upload to AWS, because AWS is slightly hard to get an account. We can still do it. I have an account, so I can use my AWS account credentials as well. But if you want to do it, you can use Cloudflare. I'll probably go with Cloudflare. Does not matter either way. The code remains the same. You just flip a configuration parameter a little bit to store it either on AWS or on Cloudflare. We are going to use Cloudflare for this tutorial that you can easily create an account for. So next step is go to cloudflare.co and sign up or sign in. Once you sign up, you should reach a page that looks like this. And here you will find R2, which, as you can see, has sort of an object store right next to it. If you click on it, it will most probably ask you to create, like put in a card, but most cards work here. A lot of cards work here, but not work on AWS, or it might just work without a card as well. I'm unsure. If it does ask you to create a card, shouldn't be too difficult. I mean, if you have a friend's card, put it in. If you have your own card, put it in. It doesn't charge you. It's also like sort of free for a really long time. But you will have to, I don't know, unsure if you have to put a card here. If I had to guess, I think if I remember correctly, you do have to put a card. Once you do that, do it on either place. Does not matter if it's Cloudflare or AWS. Once you do that, you have to create what's called a bucket in both either AWS or Cloudflare. A bucket is a place where you put all of your application files. Basically, you could have multiple applications, right? We are creating Vercel today. Tomorrow we might create Zerodha. Day after we might create a social networking app. You want to structure your application better and put all your Zerodha code in a separate bucket. Bucket basically means a central place where you're storing this. So for our application, generally it might be a good idea for you to create a new bucket and call it Vercel bucket or Vercel works. And select automatic here and click on create bucket. Once you do that, you have a place on the internet where you can dump files. Basically, think of this as Google Drive. Okay, you can put your files here. As you can see, it also lets you drag and drop. But we are not going to drag and drop. We are going to use code to write some logic here that will take all of these files and one by one push them on this bucket right here. Does that make sense? Are we good to go? Shall we proceed? If this was a live class, I would have asked that. But if not, feel free to pause, go back, try to find a friend's account and then get R2 credentials here. You also have to do one more thing after this. So let me explain that also. After you've created the bucket, you need a few things to actually put data there, right? You cannot randomly put data here. You need some secrets. You need to create a password basically that you can use in your code right here. So I would urge you to do that next. A few things that you need handy is number one, this account ID. This can be public from what I know, I think. And lastly, manage R2 API tokens. The second thing you need is this. This is important. These tokens will let you actually, put some data inside Cloudflare. So click here, click on create token, give it whatever admin or object read and write. Yeah, object read and write works. You don't need to give them admin rights. I'm going to give admin rights. Doesn't work either way. That works either way. Keep this empty, and click on create an API token. As you can see, it gave me an access key ID and secret. I will of course revoke this before the video goes live so that you don't reuse it or spam it. But these are things you have to keep handy. So let me copy these over to my code base. Would urge you to do the same if you have reached this point, because you can't get the secret again and again. So copy this access key ID, the secret, and this third URL as well, and keep it handy in your code base somewhere. All right, I've done that. That's enough. That's all you need. You have all the things that you need to do in this GUI, and very similar steps you can take on AWS as well. Go to S3, create a bucket, create credentials for that bucket, create credentials that have access just to that bucket, and then put them here in your code base somewhere. We'll eventually see where you can use these credentials to put data either in S3 or in Cloudflare. Let's move on to the next step, which says write a function that uploads a file to a given path in S3. This is important. If we've written this, then all we have to do is, as you can see, the next step, iterate over all the files. So write a function that uploads a file given a path to S3, because we already have a bunch of file paths. We need to write the function to actually upload it. Let's do that next. All right. What did this section expect? It expects you to create a function called upload file that takes a file name as an input and a file local path as an input. And you have to write the logic to upload this local file on AWS or on Cloudflare on this file name. If you look at the file name, it's not just src/app.jsx. The input file name is by the complete path where you want the final file stored in S3. Just because your file is present locally here, you don't want it stored on S3 also here, right? S3 also lets you create a directory structure. So if I open Cloudflare here, I can upload objects here. I can either put all of them in the root folder, or I can create subfolders, similar to Google Drive, right? On Google Drive, you can create folders, and then inside a folder, you can create another folder inside which you can put your file. When you have a project, when you have a user who's uploading something on your website, you want to structure each and every one of them separately. So what you can do is, every file for this specific project will go to output/1231 or whatever is the ID for that project /source/ the file name or whatever the file name is. And the second argument it expects is the local file path. Where can I find this specific file locally, the one that I want to upload? All right. Given these two, we have to write the function that actually uploads the file. So let me write that next. That wasn't too difficult. What I had to do was first initialize an S3 object, const S3 equal to new, capital S3. Where does this come from? It comes from the AWS SDK. The name itself says SDK, Software Development Kit. This module package library lets you use a bunch of AWS constructs. The one that we are using today is S3. And what does this let you do? This lets you put files inside an S3 bucket. First, initialize your S3 bucket by giving it the access key ID, secret, and endpoint, the three things that I asked you to copy over from the Cloudflare dashboard. If you're doing the same thing on AWS on S3, you can replace, you don't need the endpoint because by default it will hit the right endpoint. You just need an access key and a secret that has access to your specific S3 bucket. This is good enough. This has all the permissions now to put data inside your bucket. Given that you have those permissions, what do you have to do here inside the upload file function? Okay, bhai, given this local file path, should probably be local file path. Didn't matter in this case, but yeah. Given this local file path, I need to read all the contents of it by using, so there are multiple ways to do this by the way. This isn't the only way. This is actually the worst way to do it. But one way to do it is read file sync, which means synchronously read this file and put it inside this file content variable. Given you have this, you do a s3.upload and the arguments it expects it. What is the body that you want to put? What bucket you want to put it in, which in our case, I created the Vercel bucket. And finally, what is the key of where you want to put? What is the relative path in the bucket where you want to put it? Why did I not put local file path here? If I would put local file path here inside Vercel, it would start storing it in /users /Harkirat sync /Vercel /dist, so on and so forth. And we don't want that. We want a slightly cleaner directory structure here, which is why we have two arguments: the cleaner place you want to store it and the original local path. And what is the key? Where do we want to store it? The cleaner place, the simply output /123 source /app.jsx. And as your project ID changes, this specific thing would change. That's all you need for this function. I've added a dot promise here. This is the new way to promisify functions. What is a promise? Out of scope for this video. But for the people who do know, this lets you promisify this function call, which is why you can await it. And the way I know this actually works is, as you can see, currently my Vercel bucket is empty. But if I make this function call for now, just to test inside index.ts at the top. So right after my imports, I do a basic function call just to make sure whether or not this upload file function works. I give it an input of a random file that was generated for an old build, which is present here in dist/output. I have a bunch of these now that we've been running it a lot of times. I took a random file here, put a random path. I can put whatever I want here, like Harkirat /a.json or, package.json. That's the path where I want it to be stored. And this is the local path of the file. If I save this and I try to run this, which again, the commands remain the same, tsc-b to actually compile it, or npx tsc-b, and then node dist/index.js. If I wait for this and this upload file, as you can see, finally does succeed. It gives me a nice log. And the better way to look at it is just go to your dashboard and refresh, and you will see Harkirat/package.json is a file here. Harkirat/package.json, the input path that I gave. You've sort of created, this is like Google Drive, right? So you're just uploading it. Rather than uploading it through a UI, you're uploading it here via a library through your code, which is exactly what we want. We want to clone the project and then put it, all the files on S3. We have the wireframe for it. The only thing that's left is to actually put data here. So let's wire that up in the next step. If you look at the next step after this, it is iterate over all the files and upload them to S3 one by one or together. There are two, like one optimal way, one slightly unoptimal way to do it. We'll look at the just easiest one and do it. But this is the next step. Would urge you to try it out yourself. You already have everything, right? You have the upload file function. You know the arguments to it. You have all the files that you need to upload. How can you use this function to upload all the files one by one onto S3? Think about it. I'm going to code it myself here. I was able to do it. I hope you were able to do it as well. What did I do? I iterated over all the files. I did a files.forEach await upload file. This is important. What arguments do you give it? You can, for the local file path, it's straightforward. It's the final file path. If you remember, the thing that we were logging was the complete path to the file. So /users/Harkirat, the whole thing. But what should be the first argument? How can you find the first argument? How can you, given you have, /users/Harkirat/ Vercel /dist/output /123/123 /app.js, let's say. Given you have this, how do you extract output /123/123 /app.js from it? How do you extract just the last part right here? You can think of a few ways. You can split it via slash and find the last part. You can find where output exists. 10 different ways to do it. The one that I've done is file.slice, which is a function that you can run on a string. This is file.slice, which means remove the first these many characters from this string. And what is these many? __ directory.name. What is __ directory.name? It is this thing. That's what __ dir name is. Dot length, which means the length of this thing. +1, which means this slash as well. If I do a file, which is this whole thing, dot slice this part, everything from the beginning until this slash, then we're good to go. And that's exactly what I've done. __ dir name dot length, which basically means take out everything that's the length of the number of characters in the directory, +1 because we want to take out slash as well. And what will that do? What will file.slice this specific length do? It will remove this and you have out a very clean, trimmed down path of where you want to store your final file. If this feels overwhelming, try to play with the slice function. Let me open a console here. Const x = 1, 2, 3, 4, 5. x.slice1. What does this do? Removes the first character. Let me do x.slice3. What does this do? Removes the first 3 characters. So x.slice, whatever argument you're giving, you remove as many characters from that string. And what have we done? File.slice __ dir name dot length +1. So that what is dir name dot length? All the characters from here to here, that's whatever this is, 20 +1, 21. So remove the first 21 characters, which leads you to this clean output. That's all you needed. You can do it different ways as well. You just need to make sure the first argument is a clean argument. The second argument is the local path, the real path of the file. Given that you have this, if you want to actually try it out if it works or not, recompile the project, rerun it, and we have done this function call where inside the endpoint, which means we can literally call this /deploy endpoint and it should just work hopefully. So go to Postman and hit the endpoint. Look at the logs. In my case, as you can see, a bunch of upload logs because my upload file function here logs the response at the end. I see a bunch of upload logs, which probably means things are working as expected. If you go, what is the response that I got? I got UMHJL. That is the ID of my current build, the one that I've posted. If I go to Vercel, refresh the Vercel bucket, go to Cloudflare and refresh the Vercel bucket. Inside output, I see my UMHLJ, which basically means my code is working as expected. I was literally able to take a repo URL from a user, clone it on my machine, and then put it on an object store. The object store that I chose was Cloudflare, but you can use the same code and upload it to S3 as well. Nothing really changes. It'll just work for you if you just put the right credentials here in where you've initialized the S3 object. If you put your S3 credentials here, it'll upload it to S3. We took Cloudflare credentials, so it uploaded it to Cloudflare. Does this mean we're done? We pretty much seems like we've done everything. If you remember the architecture diagram, which I'll put somewhere here in the video, I said first clone the repo locally, then put it on S3. What was the next step? It was to put it inside the queue. Given this ID you've generated, you need to tell the deployment service, "Ke bhai, I have the local copy of a file. It is your time to actually deploy it, actually build it. So you need to put this in a queue." What was the queue that Vercel uses? They use SQS. What is the queue that we are using? If you remember, I told you we're using Redis. So we will use Redis also lets you basically create queues. Very similar, simple API to push to a queue and pop from a queue. So we're going to use that. You can totally use SNS, but you will need an AWS account for it. So if you have an AWS account, very simple API to use SQS and put to a SQS queue. If not, RabbitMQ works, Redis queues work. We are going to use Redis queues. So now I'm going to write some code that given all of this is done and you have access to the ID here, how can you push it to a queue so that a different Node.js process can pull that queue and start to deploy files one by one. All right, I've combined the next 3 steps together, or maybe 4. The next thing that you had to do was you basically need a queue, right? A persistent queue that's not passed or this part of this Node.js process. It's just present somewhere else. So there are many ways to create queues. You can use SQS. We're using Redis. So the first thing you have to do is start Redis locally. For those of you who don't know what Redis is, Redis lets you do 10 different things. The specific service of Redis that we're using today is queues, which basically means if you have a Node.js process, that Node.js process can actually push something to a Redis queue. So if you start Redis locally, you can run a command called like lpush or rpush, which basically means I want to push either from the left or from the right to this Redis queue. So let's say I do a lpush of 1, then we will put that's equivalent to me putting 1 on this queue. And then another Node.js process, maybe the deployer Node.js process of ours or publisher, whatever you want to call it, can pop from this specific Redis queue. So it can run a, what do you think it should run? An rpop or an lpop? What is lpush? Push to the left. What is rpush? Push on the right of the queue. You probably want first in, first out, right? If some project was pushed here first, you want to pull it out first. So if you're pushing from the left, where should you pop out from? Probably from the right. I think I'm right here. So push to the left, pop from the right, so that as the queue gets filled, the first thing that got in gets out first. And then the publisher can get this specific ID, which if you push 1 here, it'll get back 1. And then it can, do whatever it has to do, which is, actually build the project. So what do we have to do? Number 1, start Redis locally. Number 2, initialize a Redis publisher. So in Node.js, if you want to start to push things inside a queue, you can do this. Const publisher equal to create client, where create client comes from Redis, and do a publisher.connect. You basically need these 3 lines of code to initialize a publisher, something that can publish to Redis, something that can put things there. You can put a bunch of things in Redis. We're just using queues right now. So where will we use this publisher? If you scroll to the bottom here, after all the files are uploaded to S3, everything is done. I do publisher.lpush build-queue, ID. I say this is a new queue where I'm pushing some things. And what is the thing that I pushed? I just pushed the ID so that the other service can pick, ki, haan bhai, this ID is done cloning, done uploading to S3. It can be pulled out and actually deployed. How can you confirm this is actually working? You can start this project locally. You can go to Postman and send a few requests. And if things have worked correctly, then publisher.lpushed should have been called, which basically means you should have ideally, hopefully, published this to the build queue. How can we confirm that the length of the queue? How do we know what has been put in the queue? And the answer is, there are a few ways. Like you can use the Redis CLI, which is the easiest way. If you did start Redis locally, and there are a few ways to start it, but if you started it in the most raw way, then you can run wherever you installed Redis, which in my case is harkirat/project/redis table/source. I can run ./redis-CLI here, which, what does it say? Redis CLI, command line interface to talk to Redis. So here I can run any command that I can run here. If here I can do an lpush or an rpush, I can do an L push or an R push here as well. I can also do a pop, and that is exactly what I will do. If I do an R pop build dash Q here, it gives me back Q7DUD. Is this exactly what we got in Postman? Yes. What does that tell you? Okay, bhai, whenever this function is running, the project is actually getting cloned in Git into the local machine. It is getting uploaded to S3. And then lastly, it is being published to the Redis queue as well. And someone else, a different process, can actually pop it off. How can I confirm that I was able to pop it off? I started a separate process here. I started the Redis CLI and I was able to pop things from the queue, which basically means I now can start writing the code of this second service that can pull things from this queue and start to process it. All right. Hopefully that was straightforward. Maybe not, but let's write some code. I don't think there's anything left here. Use Redis queues. There are two more things here. We can get to it later on. We can do it right now as well. Let's get to it later on. All right. Feel free to ignore this point and this point. We will need it eventually when we reach the front end bit. For now, it's totally fine. Feel free to ignore these 2 points. We have a great starting point. We have created the upload service. Next up, let's create the deployment service. All right, to set up some context now, what have we done? We have done the first part. We have created the upload service. What do we have to do? We have to create the deployment service, create the request handler service, and then create the front end. So there's a long way to go, but this was the most difficult one. Everything else isn't too difficult. We can actually copy some code from what we've written already. So things should be slightly smoother from here. I'm assuming in an hour and a half, we should be able to finish the project. Let's get into the next section, which is page 2 here on daily code. So if you're on the website and if you've done all of these steps, but the last 2, we can get to the last 2 later on. You can now move on to the next step, which here is deploy the service, or the deploy service, which will actually build the project, pick things up from the queue, and then, do all the jazz that we discussed in the initial bit. Let's get into it from the top. Let's start to build it incrementally. All right. Step 1 is initializing an empty TypeScript project. Right, that was pretty straightforward. Just run the 2 commands, which are npm init-y and npx txt-init. Step 2, configure tsconfig.json. Do it however you want to do it. For me, again, it's going to be root dir. I'm going to change to /source, and then out dir I'm going to change to /dist. Third step, create an infinitely running for loop that pulls the values from a Redis queue. This one is important. Now we're getting to the meat of the logic. We need to create a for loop that keeps on running again and again. And what does it need to do? It needs to check, is there something in the queue? And if there is, it needs to get that value. That's all. Just log the value for now. Eventually we'll see how we do more things with it. For now, just log the value. All right, I've written some code and I just realized I missed a point here. The point being installing all the dependencies. So what do you have to do before you write any of this code? You need to install all the dependencies from npm. The way to do that is npm install Redis AWS-SDK, and I'm unsure if we need another dependency, but I think these 2 should be good enough for now. After I've done this is when I should have written this code. And if you look at the code, what does it do? It first creates a subscriber this time. Just the variable name is different. You could just call it publisher, does not matter. Does the same thing. It says const subscriber equal to create client and subscriber.connect. And then I've defined a main function which has an infinitely running while loop. We also call this function right here. And what does the while loop do? It does a subscriber.brpop, which means pop from the right side from this build queue. Harkirat, what is this syntax? What are these arguments? Why are there more than 1 arguments? The answer is this npm.js module right here. I went to the docs, searched for rpop and reached this section. And that's how I sort of wrote this code. This probably has some significance, no idea. 0 probably has some significance, no idea. If I had to guess, 0 probably means you want to stay here blocked. It's probably a timeout. So, if this was 10 or whatever, 10 into 1000, this probably would mean, wait here for 10 seconds. And if it does not, nothing comes in for 10 seconds, break out or, throw an exception, I don't know. And 0 probably means, wait forever. If the queue is empty, the code will remain stuck here, basically, is what I feel. Could be wrong. By the end of it, I'm just logging response now. I want to see if this works as expected or not. If this is able to actually pull things from my locally running Redis. A good question you might have at this point is, Harkirat, where did you give your Redis credentials? Where did you give where to hit Redis? And the answer is, since it's running locally, Redis subscriber.connect by default connects to your local Redis, which usually runs on localhost : I totally forgot, 2473, I think, or 6473. Something like that, some port like that. So if you're running Redis locally, this much should be able to connect to the Redis, call it database, call it cache. Redis has a few names. Let's see if this works as expected or not. Let's see if it's able to pull out things from the queue. So what I'm going to do is, number one, start this process. And number two, while this is waiting here, in another terminal, let me open another terminal, maybe right next to it. So terminal. In this other terminal that I've opened right next to it, I'm going to go inside the Redis that I have installed locally and run redis-cli and start to publish things on the queue. In the last video, I was publishing from Node.js and subscribing from here. Now I'm publishing from the CLI and subscribing in Node.js. So just doing the opposite. How do you publish from here? lpush space build-queue, the name of the queue, space the element that I want to send, which let's say is 123. If I press enter, I see something reached here, which means things work as expected. If my original Node.js pushes something to the queue, this will be able to pop things from the queue, which is a great starting point. We're able to at least make two backend systems communicate with each other. If I send a lot of these one by one, my server will be able to pull them one by one and process them one by one. That's exactly what we wanted. So the first step here is done, which was create an infinitely running for loop that pulls the values from the Redis queue. I created a while loop, doesn't matter either way. It's able to pull values from the Redis queue infinitely. Now I need to write all the processing logic here, the logic that actually pulls the code from GitHub and then, not GitHub, S3 actually runs npm run build and then pushes back the HTML, CSS, JavaScript files to S3. All of that code we have to write next. What's the next step? Write a function called download S3 folder, another pain in the butt. A function that, given a folder URL or a prefix /out/12345, it's able to pull everything from S3 locally to its machine. What do we want in this step? We want ke bhai, step 1 mein someone put something on /output/some random ID. The first process put something on S3 or whatever, R2 in Cloudflare. Now I need to pull all the contents out from here into a Node.js process. I need to pull all the contents from this folder from here into the Node.js process that I'm running, basically in a folder in my machine. How do you do this? You implement a function called download S3 folder, which takes what as an input? A prefix, which is where do you want to copy this from in your S3? What is the folder location of that specific asset? And what will we put here? What will we call this with? Can you guess already? It will be /output/ whatever this returns you in response dot. What's the type of response? We logged response, right? Response dot element. All right, something is up with TypeScript and the types of what this function returns. When we logged, I saw that this function returns an object that looks like this. It has key build queue element 1 to 3. But if you look at the type of res here, it returns string for some weird reason. So to get around this, for now, I'm doing a TS ignore, which is bad practice, basically telling TypeScript to ignore a specific error and doing something like this: const id equal to res.element. And as you can see, without the TS ignore, it gives me an error, and I'm ignoring the error for now, something you shouldn't do in production. But for now, this library is giving me very weird and wrong types. The value that it returns, that it thinks it returns is a string, or it returns something else. It returns an object, which is why this is not working. And just to get around with it, for now, I am ignoring the error. That is what TS ignore does over here. All right. Given I have this ID, this specific ID, 1, 2, 3 was the ID that I pushed. Here, I'm able to grab that ID here. What folder do I want to pull from S3? I want /output/ID. If you remember, this is where we were storing our final set of assets. If I go to Cloudflare and if I open S3 or whatever their object store is, R2, if I go to Vercel, where were we storing all the objects? In output/the ID of that specific project. So where does download S3 folder need to download everything from for that specific project? From /output/the ID of that specific project. So that is what prefix is here. Now we have to write the actual logic that will pull all the code from that folder over here. All right, let me now write that next. All right, I was able to write it. I worry if you're looking at this code for the first time, the promise logic is going to be a little overwhelming. So let me take you through what I've written. You can also think of this download S3 folder function that I've written as a black box, like make an AI write it for you and just make sure it does what it does. But if you want to understand the syntax, here it goes. You have the prefix. You have to download all the files from this specific prefix. What would prefix look like? Something like this: output/some path. That's what the function that is calling it right here passes in. Initially it had a /output, that is incorrect. It is going to be output/ the ID of that specific deployment. Given that you have this prefix, how do you download all the files locally? You first list all the files there. You can run s3.list objects v2. Okay, by in this bucket with this prefix, give me all the files. This will return you basically an array of all the contents over there. If you iterate over all files.contents, this will pretty much, this logic that you see here will pretty much run for every file in there. For example, /output /asd /index.html, and then the same logic would run for another file there, index.css, so on and so forth. Inside this logic is where you have to actually store / copy the file locally. And that is not too hard to understand if this is the code that I wrote, which is basically, see. All right. If this was the code that I wrote, it would have been slightly easier to understand. Okay, by given all the contents, given all the files, I iterate over them. This could also be a for each, doesn't have to be a map. I iterate over all of them, get the final path where I would store it locally. What would that final path be? The current directory that I'm in, that is this /dist. That's what _ dir name has, /output / whatever the ID of that specific deployment is. That's probably where I want to store the file, right? In dist /output /NID. So that's what we can get in this variable. Then we find the output file. This is something new. Okay, this is a fs.create_write_stream. This is if you want to download something from the internet, there are a few ways you can download the whole thing together, or if it's a very big thing like a file, you can download it in chunks. That's what create_write_stream lets you do, as the name suggests. I mean, this is a Node.js API to know. Do you have to know it? Probably. For cases like these, you need to know how to, download a big file. And for that, and this is not just true for downloads. Even if you have to, load a big file locally, then also you can create a write stream and do it. If you want to copy over a file from the same network from a different person, you can use the write stream. We can go deeper into this at some video, but high level, what does this do? It creates a stream from which you can get some data, stream some data from AWS, and eventually put that in an object here. So what does output file variable contain? It contains the final object of where you can put a stream. Then lastly, we do some logic here, which is to make sure that when you're copying files, the directory in which you're putting a file actually exists. You don't want to copy something in, /dist /output /123 /src /index.js when /src doesn't even exist. So the logic over here in these 3 lines just makes sure that bhai, whatever file came, path.dir name means if the file that came was this, then path.dir name would, if you run path.dir name on this input, it'll give you this. Okay, this is the directory name of that path. And what does this function do? It checks, bhai, does this directory exist? If it doesn't, it creates it. Just to make sure before you actually copy the file, something exists, that there is an empty folder there at the very least. All right. That is why I had to add these 3 lines of code. Even if you don't do it, I mean, it'll break. This won't work without this. You need to, first create the directory structure, and only then can you pull a file there. Would have been nice if I could pass, some argument here. Create write stream, create folder if not exists, true. So if this write stream expected or gave an argument like this, I wouldn't have to do all the fancy logic. But since it doesn't, most probably it doesn't, I have to manually create a bunch of folders. And then once the folders are created, I can simply copy over the file. That's what this specific function call does. What does it do? By get object from S3 and create a read stream and pipe everything that is being read to output file, which was the write stream right here. So this might feel a little overwhelming. Wouldn't be surprised if it does, but let me just put this together if it makes it slightly less overwhelming. Create a read stream, write stream, and get everything from AWS in a read stream, pipe all the output here. If you don't understand it, so mostly fine. You don't thankfully write a lot of this logic yourself. In a lot of cases, in this case, we're creating a very nuanced thing of copying over things from S3 over to your machine. And I'm also sure there's no easy way to do this, but if I had to copy a file from, a URL like this, google.com/a.jpg, Then there are like easier APIs. You can use Axios to do something like this. So my basic point is, even if you don't understand these lines of code or this function at all, feel free to take it as a black box. But if you can understand it, it's better. Even if you don't understand it, it's fine. This code is good. Again, let me take you through it from the top because I think this is a little overwhelming of a code. What does this function need to do? Bring all the files from this prefix on S3 locally. What do? We initialize the S3 object, give it the right credentials. We get all the files in a variable. All files.contents is going to be an array that looks like this. This is one file, and then this is another file, so on and so forth. It's an array of strings. Given that you have this array of strings, we iterate over them and one by one bring them in our machine. So how do we do that? Get the full path of where you want to store it locally, underscore dir name, comma, the actual key of the object, which is this or this. And then once you have that full path, you create a write stream and route everything from S3 into that output file. This is a little bit of a syntax to chew, unfortunately, but I can give you more examples in the future of read streams and write streams and how you can do various other things with it. This is just one thing that you can do with it. Given that you have this, you have to next promisify it to make sure that bhai, this function only exits when all of this file has been copied. I repeat, you're running this code, and this is sort of asynchronous code. You don't immediately get all the files from S3. It might take a minute, it might take 2 minutes. You should ideally wait here for a minute or 2 minutes. Make sure that everything has been copied, and only then should this function return. What do I mean by return? I mean only then should the function control reach here. For that, you can promisify this section right here. What does promisifying it mean? Basically means converting this into a promise and then await on all of these promises right here. For that, you need to know the promise.all API. So if you don't understand promises yet, if you don't understand create read stream yet, feel free to take it as a black box. Let me revert back the code to the original code, which is the promisified version of this, which looks something like this. Okay, bhai, we are iterating over all the contents and we are getting back a bunch of promises. As you can see, it says return new promise in this all promises variable. So by the end of it, when this map runs again and again, all promises contains a list of promises. What is a promise, Harkirat? Out of scope for this video. If you don't know it, you don't know it. Take it as a black box. You get an array of promises and then you can await on all of them so that this function only exits after all the files have been copied. In Hindi, ये काम क्यों करना पड़ा? ये काम इसलिए करना पड़ा, ये promiseification क्यों लिखनी पड़ी, और ये इतना गंदा, इतना लंबा कोड create read stream क्यों लिखना पड़ा? ये इसे लिखना पड़ा क्योंकि if you have to copy code from S3, यही तरीका है, कोई और तरीका है नहीं, और तरीके होंगे, but this is the simplest way to copy over stuff. Feel free to take it as a black box. AI लिख देगा, Stack Overflow लिख देगा, मैंने भी Stack Overflow से copy किया. तो this section is just the way to copy code from S3. और ये सेक्शन क्या है? ये है इसको the why we had to do this is कि भाई ये फंक्शन रिटर्न नहीं करना चाहिए जब तक सारी फाइल्स नहीं आ गई. Until all the files have been downloaded, this function shouldn't return. We shouldn't move on to the next step. We need to wait for all files to come, which is why we had to promisify this function, because this does not have a very clean promise API, and then we awaited on all the promises. नहीं समझ आया? It's fine. If I were to guess, I would say 40 to 50% understood, and that to people who had some experience. So you're in the 50% percentile, which is fine, and you don't have to worry. I mean, you can choose some class and understand it, code it, but even if you take it as a black box for now, you're fine, because there are a lot of things to cover, and we can spend a lot of time here, but I don't want to. So would urge you to try it out. This code you can find here on daily code if you expand this specific section. So try it out locally, try to understand it, spend your time with it. As you spend some time on it yourself, you'll be able to understand it better, hopefully. Cool. Let's try it out locally. Let's see if this actually works or not. For that, I'm actually running an infinite while loop, getting something from the queue, and then getting the final element and calling download S3 folder. Let's see if it actually downloads it. So if you take this as a black box, what does this have to do? We have to make sure that bhai, if something gets put on the queue, for example, from this terminal, that something, the files for that specific ID get pulled on my machine. Let's run this code locally. I don't see any logs, surprisingly. Maybe I did not put any logs here. That's my bad. I had a small bug in here. The dot on needed to be finish and not, what was it? End. This basically meant that the promise wasn't resolving. So my code was stuck here on this await promise.all. It felt all the files hadn't been downloaded, even though all the files were downloaded. So small bug here, replace this with dot finish. And now if I read on this project, how I debugged this, if you want to know, I saw that the files were being downloaded, but the promise wasn't resolving. And so I put a log here and I saw the log, the control never reached here. And then I Googled and reached this specific point. Alrighty, let's push something to the queue and it says awaiting and it says downloaded. Waiting. And where is downloaded logged? Right here, which means if I go to dist, I go to output, I go to this folder, I see the files have been pulled from S3 to my local machine. Cool, this step is done. What's up next? What do you think is up next? I need to run npm run build to convert the React code into HTML, CSS and JavaScript. Bonus if this is containerized. So I'm not going to containerize it. It should be fairly easy to containerize it. If you open this result, by the time you're seeing this video, you'll see both the versions. You'll see the containerized version and the non-containerized version. If you know Docker, it's not too difficult to build the containerized version for this, but let's create a simple one right now. Okay, given that I have this specific, folder that I've downloaded files from, how can I run npm install here first and then run npm run build here after this succeeds? And then whatever assets are created here, the index.html file and everything else, I can publish to S3. These are the three things I have to do. First two things I have to do is run npm install followed by npm run build. So that's what you have to do in the next step. It says run npm run build to convert the React code into HTML, CSS files. That's the next step. Let's do that right now. All right, I've written a function called build a project. It's funny because you shouldn't write it ever like this. You should containerize your application, but to kick things off the ground, I've written a very janky version of it. Basically how you can run it, this will mostly work. If you're creating an auto scaling server fleet, it doesn't even matter because every server will independently pick a process. So even if your end user has some LNS code, some security vulnerability code, you are not too worried about it because the server starts, you run it, the server stops. Even if something bad happens, you're good. Nahi samajh aaya, don't worry about it. The point is, okay, this isn't the best way to write this code. I would ideally containerize it, which shouldn't be too difficult. You just need to change this to something else and it'll work. But let's understand what we're doing right now. I say that by the build project function will take an ID as an input. Okay, bhai, this is the specific ID of the project that's being built. You already have copied it over. If you look at index.ts, first you downloaded the folder. Once the folder is downloaded, you have everything in output/id, is when build project gets called, which actually builds the project. Ignore promisification for now. It will still work without the first 2 lines of code and this line of code. So you don't have to worry about the promise. Why do we need promises? Why is promisification good? It is good because you want to await build a project. You want to wait for this function to completely build and only then move on to the next item to pick. And if you want to await on this, there's no easy way to do it if you're using spawn or exec. And for that reason, you have to promisify it. What does promisification do, Harkirat? It basically, rather than returning any value here, this function returns a promise, which means something that will eventually resolve, something that will eventually exit, and you can await on that promise here. And when do we decide that this thing has exited, this thing has finished, is when this function gets called. Now the syntax is a little complicated if this is the first time you're seeing it, especially, new promise, which takes a function as an input. So again, if you want, feel free to take it as a black box. If you want for now, even if you comment this out and if you just write this much code, it's fine. It'll still work for you. All right, cool. Given that this returns a promise, which we ignore for now, what does this code right here do? It says, "Ke bhai, I want to execute." What is exec? It's something that Node.js provides you out of the box from this module of it called child process. It says child process, which means this Node.js process starting another process. That's what we want, right? Our node code is running and it is able to run npm run build in a different folder. So for that we use exec. And what does exec do? Or what does it take as an input? Again, this is not the cleanest way to do it, but for now I did, by change the directory to the dist folder plus output/id and run npm install and run npm run build. So if I take this command and run it in my terminal, what will it look like? I am in the dist folder and I can run by cd into ./output/a and npm install and npm run build. That's what I want, right? I've copied over the folder. I need to build this. I need to spit out the final HTML, CSS and JavaScript files. So I need to run this. Only I need to run this programmatically, which is why this is the code that I ran. This just gives us some extra logs. As this child process is logging something, log them here as well. Child.stdout.onData, log it here. stder.onData, log it here. Even if you remove this, this will totally 100% work. But it's good to have it if you want to see the logs. This is how I was able to debug whether or not it's working or not. But if I comment it out, it's fine. The more important thing is child.onClose. When you know this process has exited, the child process that you started exited, which means npm run build and npm install and npm run build finished, is when control reaches here and you can resolve the promise. You can be like, by whoever was awaiting on me, I'm good to go. I'm done. My final thing has completed. Please move on to whatever you're doing, and it can pick the next thing from the queue and go from there. Cool. So I've written download S3 folder. We have written build project. And if we run this with these logs, you will see some very nice logs. You will see it actually basically run in production and run how it should work. So if I build this, if I run this, you will see something got picked, it got downloaded, and then a bunch of npm logs. What are these npm logs? This is the node project building, which means your code is now downloading something from S3, downloading the specific ID, specific project that you wanted to build, and then it is building that project. It is taking React, converting it into HTML, CSS and JavaScript. Harkirat, where can I find this? You can find this here, right? If I go to dist/output/ whatever is the file that we're currently working with, or the project that we're currently working with, here there is a dist folder inside it. I repeat, I am already in dist/output/epwic. But this in itself is a React project, right? This is my React project that was originally on GitHub, then got put onto S3, now got pulled on this specific directory of mine. And here I ran npm run build. And so the dist that spit out from here is my final HTML, CSS and JavaScript code. Feels like recursion? It might, but hopefully this was straightforward. What exactly is happening here? At least logically, We understand that we are first downloading everything from S3 in this process and then building the project. What is the next step after it? After you've built the project, you have something in the dist folder. What do you have to do with these assets? You have to put them back into S3, go back to the original system design. There were two parts of what is stored in S3 by the end of it. The original React code that's already there now, and this new code that you are creating, the final output that you are creating, which has your HTML, CSS and JavaScript files. This is what we need to put in S3 next. So if you look at the slides, what was the next step? It is write a function that uploads the directory to S3, and you can copy it from the last module. We have already created this, thankfully. We already know if this is an input directory, how can we, number one, get all the files inside it, and number two, iterate over all the files and upload them. So this isn't too difficult. We've already written it. I'm going to copy it. We have to create a third function called copy final dist, given this ID as an input, that we can create in the same aws.ts file. All right, I did a bunch of copy pasta and was able to get the upload file function from the last module and also the get all files function. This one, if you remember, given a folder path, gives you an array of all the files inside. For example, /output/123/index.html, comma, whatever is present in that specific folder that you're trying to find. And the second one takes two things as an input: the final file name on S3 and the local file path of what you're trying to upload. These two functions we wrote in the last module. I just copied them here. And then I wrote the final copy final dist function, which, as you can see, is less than 4 lines of code. It first gets the final path of where the final assets are: index.html, index.css, all the things that you finally built. If I open the terminal, where is that? That's in dist/output/ the ID is /dist. I need to go into this folder /output/ID/dist/output/ID/dist and copy all of these over to S3. The way to do that is first get all the files inside this folder and then iterate over all the files and upload them to S3, which again, we can use this function that I used in the past. The input, second input is straightforward, the local file path. The first input is again a little weird. The first input I've created as dist/the ID/ the local file path. What do I mean by local file path? Index.html for this file, wheat.svg for this file, assets/index/4s whatever for this file, so on and so forth. So you can log this if need be, and this will give you the actual thing that we're putting the final code on, or you can just run this locally. So if I run tsc-b to compile the code, and then node dist/index.js to actually run it. And if I put something in this queue, you will see after the project gets pulled, the project gets built, it finally gets pushed onto S3, where in dist/epwyc/ the final assets. If I go to Cloudflare, I can actually see my Vercel bucket now has two folders. It has the output folder where we were putting in the initial set of assets. This probably should have been called input, and the dist folder. The output folder has a bunch of files, but it has the epwyc, and this contains the original source code, the React source code. And if I go back to the Vercel bucket, there is a dist folder which has epwyc, which contains not the React code, but the final set of HTML, CSS and JavaScript files. Cool. That is what is expected from this second deployment service. It's pretty much doing all that's needed. It's picking up things from a queue. It's building those things, pulling it on locally, building it, and then pushing it back to S3. That's exactly what is expected from the deployment service. If you go back to the slides, this is the second last step, which was write a function that uploads everything to S3. There is one more step here, which again, I will get to eventually. Let's move on to the third part. Let's move on to the module that will handle the final requests from the end user. Given that you've put something here in Vercel or in the object store in the dist folder, you have the final HTML, CSS and JavaScript files. Next up, we need to create the request handler service that will handle the end user requests. We're getting very close, not very close, but like I think still half an hour away to building the front-end UI, or like at least taking you through the front-end UI. I don't think I'll be building it given how long this video has been. But I'll show you how it connects to these three services. First, let's build the request handler service, which should be straightforward, doesn't involve a lot of complicated logic. So let's get into that next. All right, let's move to the third section next. We need to build the request handler. This is probably the simplest module to build amongst all of the ones that we've built until now. Kick things off, initialize an empty Node.js project, add the TypeScript configurations, all that jazz. We've done this 2 times now, so I'm hoping the third time is straightforward. All right, I've initialized a Node.js project, added TypeScript to it, changed the configurations of rootheader and outheader, and have a simple index.ts file present in the source folder. Next up, initialize an Express server running on port 3001. So step 1 before that is npm install Express and add types/express, followed by writing all the code to bootstrap a basic Express application. We probably also need, we don't need courses, so we're good to go. All right, add a global route catch /star, which handles all the requests. So just to give some context, what is this service supposed to do? It's supposed to get requests like x.vercel.com/index.css or y.vercel.com/a.js. So we need a global route handler which handles all of these requests. We want a app.get everything, and for that you can do a /star, which basically means irrespective of what request is coming, it'll hit this callback. That is what this point meant. Extract the subdomain that the request is coming from. Eventually, as 10 different users deploy their application, each user will have a unique ID to identify their project, and most probably the URL that you're giving them is going to be id.vercel.com or whatever your website is, let's say 100xdevs.com. So you need to extract this ID from the request. Whoever is sending the request is sending it through a URL. You have to extract the first argument here. I think this would work. I could be wrong. We'll log ID and confirm. Yeah, before we proceed, let's make sure this code works as expected. We have a very basic Express application. We need to make sure that this host pretty much gets the complete URL. So if the request is coming from id.vercel.com, that's what gets stored in host. And if that is the case, then I think this code is correct to extract just the ID from it. Host.split would convert this into an array that looks something like this. And then the 0th value here is ID, which is what we're extracting here. All right, good to go. What's up next? We need to make sure this works. So let me show you a way to test this locally. Insightful tip generally. If you want a subdomain like, 123.vercel.com to point to localhost or to point to 127.0.0.1, you can fool your system into doing this. Ki haan bhai 123.vercel.com points to your own server. If you ever want to do this, the way to do it is open your terminal. This will work on a Linux-based machine. Open /etc/hosts and then add an entry here. Ki haan bhai 123.vercel.com points to 127.0.0.1, which means to this specific machine. Now, if I go to 123.vercel.com:3001, it will hit this backend server that we just created here. The backend server is running on 3001. If I run it, and hit this endpoint, it says SSL protocol error because I need to send a request to HTTP. And now if I send this request, it still says SSL error. There you go. If I open this in incognito window because the certificate was just cached, you will see the control reaches here. And what gets logged? 123.vercel.com. What does the ID get logged as? 123. Is this what we needed? Yes, we wanted to extract the ID of that website and we were able to do it correctly. I just tested it. How? By making sure 123.vercel.com points to my own machine. How did I do that? If you open your terminal and edit your hosts file, which is present right here. As you can see, even localhost is present here. Localhost points to your local IP. Similarly, you see a few entries here. Localhost points to 127.0.1, 123.vercel.com. I've pointed to 127.0.0.1, which is why any request to 123.vercel.com on my machine will point to this IP, which is how that request is reaching here. Cool, good to go. Let's proceed. The next section says, get the contents from S3, assuming the subdomain represents the ID, and forward it to the user. Add the correct content type header to ensure that the final file is correct. So basically do a bunch of things now. We need to firstly get whatever the user is extracting. The user is sending us a request to /index.html. We need to extract this file that they're trying to access first, right? So that will probably be somewhere here in the request object. Let's see. File path equal to rec dot, what would it be? Route. This might be it. Console.log file path. Oh, route isn't it? Is rec.path. This is what the user will send us. Ki haan, I want index.html from this specific deployment, or I want index.js or index.css. Given that we have this file path and the ID, I just need to get this file from S3 and then forward it to the user. So let's write the code for that next. Okay, given this ID and this file path, how can we extract that from our S3 bucket and forward the contents over to the user? That was pretty straightforward. Let me share what I've done. I initialized the S3 project, S3 variable, done it many times now. And in the global catch, we get the ID, which is what is the project ID that this user is trying to access, and then the file path, what is the file that this user is trying to access. Given that we have these two, we get the contents from S3. S3.get object will get you that specific object on this key dist/id/file path. This is where, if I go to Cloudflare, dist/id/index.html, dist/id/assets/whatever .js file or .css file. That is where we've stored our final content. So that's where you get this from, dist/id/the file path, and then finally const type equal to Okay, this one's a little weird. Why did I had to do this? You can totally sort of ignore these two lines, even though it wouldn't work without them. But this is good enough. Basically, getting the contents and forwarding them to the response object in Express is good enough, but this will lead to one small problem. If you just run this code and try to access it in the browser, let's say I go to, this is one of the endpoints where it's hosted. This id.100xddd.com points to my local host, which is why if I run this, I get back the index.html file, but it gets downloaded for some reason. I don't see it here. And the reason for that is basically the content type header. Your browser, based on a header in the response, comes to know what kind of file it is. And we're not passing it any content type here, which is why it gets confused and just downloads the file, thinks of it as a normal file and not as an HTML file. And so you should specifically set the content type in the header as either application/JavaScript or text/CSS or text/HTML based on what kind of a file this is. If it's an HTML file, then it will be text/HTML, CSS file, it will be text/CSS, so on and so forth. That's what these two lines of code do. In the end, it's less than 20 lines of code for you to be able to forward a request to S3 and forward the contents from there to the user. And if I now run it, you see it still doesn't work. It's probably because it's cached. Let me open it in incognito, and there you go. You have the React website finally deployed on the internet, so to say. It's not really deployed on the internet. It's on my machine right now. I've just pointed 100xdd.com to localhost, which is why this works. But in the end, in the real world, you will have a domain where you can sort of point star.100xdd.com over to your request handler service, which could be a Kubernetes cluster, could be a single instance, which will handle all of these requests. Cool. This was the second bit, or the third bit, the request handler. Let's tie all of this together. Let's start all three services locally. And then let's look at the front-end code. Let's see what kind of request it sends and how it's able to do what it did, the thing that you saw in the beginning of the video. How can it take a GitHub repository as an input, deploy it over the internet, and then, make it accessible for anyone to visit. Cool. Before we do that, if you remember, there were a few points that we missed during the first and the second section. We basically haven't created an endpoint that the user can poll to check the status of the deployment. What will happen in an application like this is, if this is your browser, and from your browser you send a request to the first server. What was this server? The upload server that was running on :3000. The browser will send a request here and say, bhai, please deploy github.com/xyz. And what does this service need to do? It needs to, there are a bunch of things that happen in the backend, right? It'll do its thing, let's say take 5 seconds to upload to S3 and then put things inside a Redis queue, which will then get picked up by whom? By the second process, the deployer. And whenever the deployer actually does its thing, builds the project and is good to go, is when the browser can actually hit the third service, which is running on 3001. So basically there's a long time before the browser knows, okay, now I can start to access this on 3001. How can the browser know the current status? How does it know, is it stuck here? Is it in the Redis queue? Is it stuck here? Or is it finished? That can I start to visit this on :3001, or it's available somewhere on the internet. One way you can do this is, okay, bhai, whenever this guy uploads, whenever this guy sends the status back, the ID back, this guy also puts in some sort of a database. Okay, bhai, for ID equal to, let's say the ID sent back was 1. For ID equal to 1, the current status is uploaded. It's not yet deployed, it's only uploaded. And then the deployer, when it's done doing its thing, is when the deployer can also hit this database. Ki bhai, ID1 is finally deployed. And the browser needs to keep polling a specific service which can expose what value does 1 have. Is it uploaded or is it deployed? So the browser needs to keep polling a service. After they send this request, get back a response, the browser needs to every 5 seconds ask, let's say this server, okay, bhai, what is the status? What is the status of ID 1? Is it still deployed? Is it uploaded? Is it up in the air? Let me know. And then this guy needs to return back, ke haan bhai. It'll check with the database, and based on whether it's still uploaded or if it has been deployed, it can let the user know, okay, haan, this is the final status. So this is the part that we need to build, an endpoint where the browser can keep polling, and this database logic where both this guy and this guy can put something in the database. What kind of database can we use? You can use any database. Thankfully, Redis also sort of lets you store data. It isn't recommended that you store data in a Redis store. You should only use this for caching. Redis isn't the best permanent store for your application, and SQL or NoSQL databases. But for now, it does not matter. So we will just use / reuse the Redis server that we're running locally to store our data inside. So if you go back to the steps here, what were the steps? Also store the current video ID's status as uploaded, which basically means tell the database कि हाँ भाई this video has been uploaded. That's the first thing we need to do. Let me write the code for that really quickly. All right. This is our original project. Which one? The very first service, the service that's running on :3000, the service whose job is to just upload the Git code onto S3. After it's done doing everything, it used to publish to the Redis queue, okay, haan bhai, I have something, please pick it up, the deployer. Right after that, I've added another thing, publisher.hset, which means is similar to like an insert statement in SQL or a .create in MongoDB. Since we're using Redis as our primary database, one way to set a value there is publisher.hset. Whatever the key is, or whatever you can think of a table is, this is our status table. This is the key to identify the specific record, and then uploaded is the current state of it. It's not yet deployed. It's just uploaded. How can I get back this value if I ever wanted? Const value equal to publisher.hget status, ID. This will give me the current value. I think I might have to await it, but you get the idea. This will give me the current value there is uploaded or deployed or something else. So this is sort of a database, not a popularly used database, but it lets you store data, it lets you retrieve data. Cool. We've been able to set data on the status database or the status table. This ID is currently uploaded, not yet deployed. What is the next thing you need to do? You need to go to the other project. You need to go to the deploy service. And here what needs to happen? Okay, by this subscriber, firstly you need to, one thing about Redis is you cannot publish and subscribe from the same client. So you need to create a separate publisher. You cannot use this subscriber to both get data and put data in Redis. You can either get data or put data, and hence you have to first create a new publisher or a new client of Redis. And then finally here, when you know you've downloaded the file, you've built the project and you've put the project back up, you can do a publisher.set, what was the thing? Status, ID, deployed. What is this one line that I've added? It is this line right here. Okay, the deployer will tell Redis that bhai deployed. Everything is done. The status has been updated to deploy. And so whenever the user is polling this service, they will know that acha, this has been uploaded. The user can now hit the request handler service because all of these steps here are done. The asynchronous bits of copying the project and deploying the project are done, thanks to us storing the data in this Redis database. Seems like there's an error to be set. All right, good to go. The last thing we have to do is this endpoint. Expose a status endpoint that the front end will poll to get back the current status of a video. The front end will poll and ask, what is the status of this video? What is the status of this video? We need to expose this endpoint on this Express server that we've already created. Can we do it on this Express server? Probably depends. You can create a new service, use an existing service, really depends on where you want to expose this endpoint. For us, we are going to just expose it in our original very first service, the upload service. I think that should work. I've exposed a new endpoint /status. It's a get endpoint. It expects an ID that the user will give you. Basically this ID right here. They want the status of a specific deployment. And then you check what's the current status inside Redis. I've also created a fresh subscriber at the top because, as I said, you can't publish and subscribe from the same client. This project only had the publisher. I now also have to create the subscriber, which is what I've done here, because this project needs to subscribe to Redis, ask values from Redis. What is the current status of this specific ID that the user wants? This is some TypeScript code, feel free to ignore. You can also write just ID here. If you were using JavaScript, we have very strict TypeScript here, which is why I had to do just force the type here for now. All right. And then finally returns the current status. Written a lot of code. Let's tie it all together and see if it actually works or not. Let's send in a deployment and then let's start to poll this endpoint and see if it actually, slowly and incrementally returns us the right value. Shuru mein it is uploaded and then finally after some time it is deployed. Let's see if that actually happens or not. Let's start the first process locally. Let's send a request to the first process. We got back an ID. Let's poll this ID and see what status we get back. It will be a get request to /status $ID equal to something, because we are getting the ID from rec.query.id. And what is this query? Any of these query parameters. This is how you send the query. I don't even need to send the body for this request. If I click on send, it says status uploaded. It is not yet deployed, only uploaded. Why? Because we aren't even running the second service. So let's start the second service next. Let me open another terminal. Let me start the second service here. It says socket is already open. There was a bug here. When I do a publisher equal to create connect, I need to do a publisher.connect here and not a subscriber.connect. Cool, simple bug. I just fixed it in Vim, did not open it in VS Code. Hopefully that's fine. Now let me, again, the status is still only uploaded. The deployer hasn't picked it. The worker hasn't picked it yet. It's still residing in the Redis queue. It's where? It's over here. What all have we done until this point? Until this point, this is what we've done. Okay, I sent a request, got back an ID, and I'm trying to poll the ID again and again, and it gives me just the uploaded status. Why? Because it's still residing in the Redis queue. It has not been picked up by the deployer because there is no deployer running right now. Let me run a deployer locally next. When I run the deployer, as you can see, awaiting. Did I remove the logs? I don't know. No, I did not. There you go. It has built the project. It has uploaded it onto S3 or R2, wherever. Let's go back to Postman and see if the status of this has changed from uploaded to deployed. And indeed it has. There we go. Our front end can now poll the application and check, is it uploaded? Is it uploaded? Yes. Is it deployed? Yes, it is. Now the user can hit, this specific endpoint. So now if I go to my terminal, go to open etc/hosts and then change this 100xd.com to this URL, which is the current id.100xdd.com. And if I start the third service now, which was the Vercel request handler, I can go to the ID of the specific deployment.100xdevs.com:3001/index.html, and it will give me back hopefully the React project. All right. Hopefully that was straightforward. Let's now see how you can connect this to the UI that you originally saw. Although I hope it's pretty straightforward what's happening there. We just have a UI that's hitting these endpoints rather than Postman, and based on the response that you're getting back, you're able to get the final URL where you can visit the application. So let's look at the front end code next. Already written it, so I'm just going to open it. So this is what the final React application looks like. I have this front end folder, which has an app.tsx at the top level, which just renders the landing page. Let's look at the code of this landing page. Now this UI project is a little convoluted, as in it uses a lot of libraries, which you don't need to know of. It uses ShatCN, it uses Tailwind. The code is on GitHub, you can look at it. You don't have to understand the styling and how this looks as pretty as it does. Let me show you what it looks like. This is what the application looks like. I need to put a URL here and click on the upload button. What happens when I click on the upload button? Let's look at it. When I click on the button, a request goes out to backend upload URL /upload. Was this the endpoint that we had to hit? No, it's the /deploy endpoint now. So we hit the /deploy endpoint on backend upload URL, which is localhost:3000. And what do we send in? We send in the URL. What do we need to send in? We need to send the repo URL. So let me change this code a bit. And what do we need to set the ID to? res.data.id, is it? I think so. So ready to this. We start an interval that polls the status endpoint on the same URL. $ID equal to something that looks right. No, that is good enough. And then if it is deployed, set deploy to true. Yeah, all right. Let me first run it. Let me show you what it looks like, and then I will take you through the code as well. I've hooked up the code to the new backend we've written. This was actually hooked up to an old backend that I had written. Now I've hooked it up to the new backend that we've created. So let me start all the services locally, start the front end and see if it works or not. And then I will take you through the source code as well. Number one, I'm going to start the, let's see. No. Oh, I opened this project. Okay. Let me open item, I guess, and I can start all the processes here. Makes more sense. Start the first project, node this, the one that's running on port 3000. Start the second one, the deploy service. Start the third one. And then I have the front end already running here, and it's pointing to the right URLs. So I think we're good to go now. Let me refresh the front end. Let me get the code of a basic React boilerplate project. Let me open the console so we can inspect all the requests. And let me click on upload. It says uploading. After it is uploaded, it says deploying and gives me the URL. And as you can see, it's polling the status again and again. Okay, has it been deployed? Has it been deployed? Has it been deployed? And at some point, if all our services are working correctly, it will deploy. And when that happens, it'll show you a URL that you can visit. Although it doesn't seem like it's happening. Let's go to the terminal and see if we're getting the right logs. No, one of these processes failed. What does it say? Let's try that one more time. Might be a bug here. seems like the deploy service has a bug. Oh, I might know what the bug is. Yeah, good thing is it's easily fixable. So I know what the bug is. I did not want to complicate things, which is why I did not fix it. Basically, yeah, this code will not be able to upload things. What is happening is publisher.lpush is happening, but these uploads haven't yet happened. We're not awaiting for all of these things to get uploaded. So you can promisify this, which is something I kept on talking about. When you're uploading files, you should promisify. Whenever there's an asynchronous function, you should promisify it, because what is happening right now is things are not getting uploaded to S3, even though this code appears before this code. Doesn't necessarily mean all of these have actually uploaded. We're not awaiting them correctly, even though it says await here, it isn't being awaited. You can do a few things. What I would do for now, just for the purpose of this tutorial, is I'm going to await here for like 5 seconds. And I think that's good enough. That will just give us a 5-second breather. And I think in that 5 seconds, everything will get uploaded. So we should be good to go. Let's try that one more time. Started all the services, refresh the page, upload, and let's see if this errors out now. I don't think it should, but I could be wrong. There you go. Seems like it worked. Going to wait for a bit. Again, we're constantly polling the backend to check the status. And at some point, if it does get deployed, which we can confirm, yeah, it seems like it's deploying. So it will deploy. There you go. It says your website is successfully deployed. You can access it here. TLD, whatever, the id.dev.100xdevs.com. This will only work when I actually point, star.100xdevs.com to a specific IP where I deploy all of these. Right now, I have just deployed all of these locally. They're just running 3 processes running locally. When I deploy it on the internet, on some server, be it a Kubernetes server, what Vercel uses, or an independent server, either way, this will just work. But right now, since I'm running it locally, I have to first change the entry in the hosts file that I shared, and that's it. If I now visit this, I think it should just work, and it does. Is this cool or not? I find it pretty cool. Let's see if this does really work, or is this just a fad. I'm just going to change this repository here. I'm going to rename count is, and put an arrow here, commit this, and then go through the whole flow one more time. So I've changed this repository. The code of this repository has changed. What I want to check is, does the final deployment change now as well? Does the final deployment has my new change that this repository has, or not? It needs to, right? I hope you get the idea. I just want to show you that there's no funny business here, and this actually works. The only manual bit now is this whole part of me opening the hosts file and adding an entry here, which we won't have to when we finally deploy this on the internet. Visit website, and here it says count is arrow 0, which is the change that I made. So it does work as expected. This is a smaller subset of what Vercel does. Vercel actually listens to your GitHub repository and deploys your changes every time a comment is made. We have not done that yet, but I hope you get the idea. Cool. Let me take you through the front-end code really quickly. We basically have a few state variables at the top, which represents the current repository URL, basically whatever you put here, whether or not it has been uploaded, and if it has been uploaded, an upload ID variable, so that you can show deploying upload ID on this button, a uploading variable, so that you know whether it's uploading, and a deployed variable, so that you know whether or not it has been deployed. If it has been deployed, then the second card renders, which is this card right here. If it has not been deployed, then only the first card renders, which does what? It gives you an input box whose value you can put in this repo URL. And then finally, a button clicking on which you send a backend request to the upload service, your very first service, and you start an interval that starts polling the endpoint. Ki haan, has the status changed? Has the status changed? And when the status becomes deployed is when you know कि हाँ भाई, the project is deployed, you set deployed to true, and the next card renders, which shows you कि हाँ भाई, you can visit the website on uploadid.dev.100xdevs.com. Now this URL is dynamic. When you deploy it on the internet is when this URL would change. What I have to do effectively, if you are really curious, is go to domains.100xdevs.com, and for any one of my domains, add a wildcard entry. What is a wildcard entry? Basically star.domain.com to point to something. So for example, I have 10kdevs.com. So if I go here, I don't know if it's too easy to add a wildcard entry, but maybe it is. Is it as easy as? Probably not easy as what I'm thinking. Let's see. Star. No, it is pretty easy then. Okay. Let's see if that works. That might just do it. Okay, so star.10kdevs.com points to 127.0.0.1, which might mean that now all I have to do is this. I could be wrong, but we'll see. Nah, that's not it. I mean, I might just take some time for this to propagate. It might not be what I've done is incorrect. It might just be that it takes some time for this to propagate. Yeah, it says unknown host right now. But at some point, either if this propagates or doesn't even need to propagate. If I deploy this on the internet, then I can literally point this to the IP address of my server, and then this will just work. Like I literally don't have to make any change. I'm thinking how long will it take for me to build the specific thing? Like, can I deploy it right now? And the answer is probably should take me less than 10 minutes. But it is 10:28 a.m. time for me to sleep. I should have slept at 5. So I don't know if I want to do it, but it's very easy to do it. I just need to get an EC2 server and run these 3 services on that EC2 server, expose them on the internet, and then point this endpoint here. And then in my code base, change, .dev.100xdevs.com to just .10kdevs.com. And that's it. That should do it, but I'm not going to. Hopefully, this was an insightful video. I think that's all I have for this one. Let me know if you liked the video. Let me know if you understood it. Basically, what I want to know is, was this fast or was this slow? And if this was decent pace or not. Yeah, that's the best thing you can give me. So let me know in the comments if the pace was right. And that's all I have for this video. Let me know if there's any other ambitious project that you'd like for me to build. Happy to do it. With that, let's end it. I'll see you guys in the next one. Bye bye.